Today, we'll go over issues that can arise when working with chromatogram peaks. We'll see what to do if some peaks are not detected, or vice versa when too many peaks are detected, or the boundaries are too wide or too narrow, and so on. So let's start with a case when the peaks are not detected. When you add a substance to the injection, if you have mass spec, then Peaksel will create an extracted ion chromatogram. And if there is a peak there, it will detect the peak on that EAC and also cascade to other chromatograms. But as you can see, while the peak is clearly there, it's not actually detected. What can be wrong? There are two possibilities. One, our integration method expects a steeper peak, or the peak area is too low. So let's open our integration settings. This allows us to see additional information. But since there could be multiple EACs on the same card, we need to activate the one we're interested in. The section that we need right now is Detect. Here we can see a curvature threshold. It determines how steep the peak has to be in order to be detectable. We can make sense of it if we click on the second derivative checkbox here. Our algorithm uses second derivatives to detect peaks, and this threshold depicted over here tells it which peaks satisfy the steepness or curvature criteria. If we modify the option, now we see a green box which is a sign that the peak satisfies the criteria. Let me increase it again, and the threshold goes beyond the peak, which makes it undetectable again. If there are many peaks on the chromatogram, we can play with this option until all the right peaks are detectable. Once I save it, the peak is selected and cascaded to other chromatograms. Another section to watch out for is the filtering. This is where we can set the minimum peak area. If peaks are too small, they will not be selected even though they are detectable. Let me increase the threshold to demonstrate it. So if you see a green box on an EAC, but the peak isn't selected, then check out the filtering. Now let me secretly break something. Okay. So you can see a peak, but for some reason it starts or ends not in the position that you expect. This problem is less trivial because it can stem from completely different settings. The one that we'll explore now is liftoff and touchdown thresholds. Basically, these tell us how far should we go from the peak apex in both directions. These options are usually useful when there is peak fronting or tailing, or the peak is located on another slope, for instance because of the baseline drift. Let me save the value, and as you can see, the peak starts to make sense now. This peak, though, also doesn't look perfect, so let me slightly increase its touchdown threshold. And now it's pretty too. Okay, let me break something again. Now the peak looks wider again, so our first thought, hey, it's the thresholds. And while it is possible to fix the problem by changing the touchdown and liftoff thresholds, the actual root cause is quite different. See, before Peaksel starts detecting peaks, it has to smooth out the signal, because there's a lot of high-frequency noise which would otherwise be detected as peaks. And there are parameters that can control how much we want to smooth. The higher the value, the more smoothing we get. You will need to set up smoothing that's applicable to your particular chromatograms. The side effect of smoothing, though, is that your peaks become wider, and in this case we set the window size way too high. If we decrease the degree of smoothing, then the peaks become narrower again, and at some point their widths will become satisfactory. This is one of the popular parameters to change if you have very sharp peaks, and you see that their boundaries are too wide. We've just covered some basics of apex track algorithm and the most common problems that you may run into. If you want to understand the algorithm better, in the description you can find a link to a more comprehensive tutorial. Now, apex track, similar to other algorithms, has one major flaw. If on the same chromatogram you have peaks or regions of very different profiles, let's say some peaks are very wide and others are very spiky, it's hard or even impossible to ensure that both types of peaks have boundaries that we want. And if you have the same substance on many chromatograms, you may not like the idea of going through each of them and do manual editing. To solve this problem, Peaksel has an ability to apply peak boundaries to other chromatograms. So if I remove and recreate the peak I see a pop-up asking if I want to apply the change to other injections. Peaksel will find all chromatograms with this molecular formula and will apply the same boundaries to the peaks. Before I do that, let's check the neighboring injection. And suppose I don't like this peak and want to apply different boundaries. I return back and I recreate the peak again. Now I apply the change to the batch, and this updates all the peaks on this type of chromatograms for this molecular formula. This, along with other batch processing mechanisms, can help greatly speed up data curation. That's it for the tutorial. Thanks for watching.